Hello viewers, I hope you are all alright. Today I'm going to talk about reciprocating engines, in other words, piston engines. So the main objective today will be to focus on what are piston engines and what are the requirements for a good working engine and what are the components of an engine, and we will also discuss about the cylinder arrangements in an engine, and we will learn about the mechanism according to which the piston engine works. So, what are the piston engines and where are they used? These are the engines which uses piston to convert the chemical energy of a fuel into the mechanical energy, and these are mostly found on the aircrafts which have a cruising speed of about like less than or equal to 250 miles per hour. And the most famous example of piston engines is Cessna 172. These are used in these type of planes. And what are turbocharger and supercharger now? These are used in the engines when the plane is at high altitude and more power is needed, so these two things are used. Now, what is a turbocharger? Here in the description, you can see in the diagram, you can see we have three cylinders and we have air intake as well. So the air enters the intake valve and it goes through a centrifugal compressor. Now, why is it a centrifugal? Because we need the air to be like moved away from the compressor. So that is why it's a centrifugal compressor. And air then passes through the intake manifold and it enters in three different cylinders. And when it passes the compressor, the pressure is very high, the air pressure, and it then enters the three cylinders, and then it is exhausted from the manifold valve, and this exhausted air will then enters in the turbine and in the waste box as well. And this exhaust air will drive the turbine, and then at the end it will be removed from the exhaust pipes, and that is why it is often called exhaust gas turbine. So the turbocharger work on like uses exhaust. In turbocharger, exhaust is used, and in supercharger, accessory drive is used to drive it. So this is the way in which the turbocharger works. Now, what are the requirements for a really good engine? Number one, it should be very efficient. It should be like, if we decrease the weight of the engine performance will increase, and the compression ratio also affect the efficiency. Now, what is a compression ratio? It is the ratio between the volume of space in the cylinder when the piston is at the bottom compared to the volume of the space when piston is at the top of its stroke. So this is the comparison between the two spaces in the cylinder is called a compression ratio. So the higher the compression ratio will be, the higher the efficiency will be. Now, number two, what is durability? It is the duration for which the engine works very efficiently and very in a good condition. So the lifetime it works reliably and it works properly, that is called the durability of an engine. Now, if we talk about the compactness of an engine, what is it? It means like it should be like engine should take as less space as possible, and the shape of the engine also matters, and especially the location of the engine. If we have like opposed shape engine, I will tell you in my next slide what is it. If we have that kind of engine, we can place it in under the propeller, and that will be the best location for it, and pilot's view will also not be affected by that location. And then again, also the flexibility, it is the ability of an engine that it runs smooth and it gives really good performance. In our next slide, I will talk about the piston engine components. Now, the number one is the crankcase. It is like a box in which the crank shaft sits, and then the number two is the crankshaft that transform the chemical motion into the rotatory motion. And then there is a camshaft. It operates the valve, like inlet and outlet valve, from where the air will go out and air and fuel mixture will come in. That is operated by the camshaft. And next is a piston. These are used in in rotatory motion. And again we have two type of valves, inlet valve and outlet valve. And then we will talk about the cylinders. Cylinders can be 2 or 4 or 6 depending upon which type of engine it is. And cylinders has a head and a barrel. And number next is connecting rods. These are the rods which provide link between the crankshaft and the piston. Here in drawing I have shown a crankshaft, and it has a main journal, the long rod, and then I have numbered the crank pins. There are 4 crank pins in this picture, and these lines along the crank pins are called crank cheeks. So a crankshaft has 3 main parts: main journal, crank cheek, and crank pin. Now, our next slide, I will talk about the cylinder arrangements. Now, there are different types of cylinder arrangements, and which gives rise to different types of engine. In the diagram, I have shown number 1, the V-type engine. In this type of engine, the pistons are arranged in a V shape opposite to each other, and hence it's called V-type engine. In O-type engines, pistons are arranged opposite to each other in horizontally. They are opposite to each other. And in inline engines, pistons are all arranged in one line. And in these 3 types of engines, V-type, O-type, and inline type engine, the pistons are even in number. Whereas in radial engine and in rotary engines, pistons are odd numbers, like it could be 3, it could be 5, it could be 7 or 9. So in radial engines, they move in rotary motion. The top 3 types of engines are liquid or air-cooled engines. Now, what is the operational mechanism of the piston engines? What is the mechanism on which they work? So, the step number 1 is intake, from which the air enters in. The piston moves down and air and fuel mixture enter into the cylinder. And then comes the compression. Piston moves up and compresses the mixture. And then we have igniters that ignites and gases expands, and due to this expansion the piston moves down. Next is a power step. What happens in this is the force is transmitted to the crankshaft, and then at the end we have exhaust. It is an upward stroke, and in the exhaust all the gases will be moved out of the cylinder. Now, if I tell you a little bit more about ignition, there are 2 types of engine designs which use spark ignition and compressor ignition. Now, in spark ignition, we have a spark plug that ignites the pre-mixed air-fuel mixture. So in compressor ignition, on the other hand, we have air in a cylinder which is compressed until the temperature rises and it ignites automatically, and then the fuel is added to the cylinder afterwards. So very simple 5 steps. Number 1, intake. Number 2, compression. Number 3, ignition. Number 4, power. And number 5, exhaust. That is all for today's lecture. To see more videos about aeronautical engineering, please click like and subscribe my channel. Thank you very much.